In this video, we're going to be ordering mixed numbers and fractions, and we're doing the same idea as the previous video. There are times when I have already typed in information. Just because it's typed does not mean you don't have to write it in your notes. You still are responsible for everything that's on the screen, whether I write it or I've already pre-typed it. So the title of your next two pages is Ordering Mixed Numbers and Fractions. So we're going to start off with just basic fractions, no whole numbers, okay? If each fraction has the same denominator, you can put them in order from least to greatest or greatest to least. So let's say we had 7/8, 2/8, and 4/8. Least to greatest, well, they all have the same denominator, so all I have to do is look at the numerators. Which one's least? 2/8. What would come next? 4/8. And last would be 7/8, and this would be least to greatest. And then I could flip-flop it for greatest to least. Well, that's all easy, fine and dandy, but you're not going to get a lot of them like this where the denominator's already the same. So what you're going to have to end up doing is LCD, like we saw in the previous video. So if the fractions have different denominators, you have to use LCD method. So let's say we had 2/3, 3/4, and 1/2. And we want to put them in order from greatest to least. Now, another really awesome strategy to use is your number line. Some of us are really good with the number line, and we can visualize where fractions go based on how we split up the number line. So I can see automatically, I know that 1/2 is halfway in my number line. 3/4, well, if I cut my number line into 4 pieces, see the 1 piece, 2 piece, 3 piece, 4 pieces, 3 of those 4 pieces would put me there. Look at that, I'm already able to see which one's greater just by where I placed it. And then 2/3, well, 2/3, I got to kind of think of my number line in 3 pieces. So that would be 1 piece, 2 pieces, and the 3rd piece. So 2/3 would go in there. And look at that, I have it already in order from least to greatest, so to do it greatest to least, I just flip-flop it. See how efficient the number line can be? But some of us are not real strong on our number line skills, so resorting to LCD would probably be your best bet. And when you get to the really small fractions, like say 7/15 or 10 28ths, number line's not going to help us a lot because some of us have a hard time cutting a number line into that many small pieces. So we're going to use the LCD method. Now, LCD said when the denominators were different, I have to make them the same. But how do I do that? Well, I look at each denominator, and then I'm going to do the multiples of them. So I've got 3, 6, 9, 12, 15, and I could keep going. That's the multiples of 3. For 4, I have 4, 8, 12, 16, 20, and I could keep going. 2 is 2, 4, 6, 8, 10, 12, keep on going. Now my LCD has to be a multiple I see in all 3 of them. Because here I see a 6, here I see a 6, but there's not a 6 in the 4 multiples. So it has to be a multiple that I see in each of the 3 groups. So I see the 12, the 12, and the 12. So that means my LCM is indeed 12, and voila, it turns into my LCD. Now, try to remember what in the world do we even need this LCD for? We need to take these fractions and make their equivalent twelfths. So I'm going to take 2/3, and I'm going to turn it into something twelfths. Then I'm going to take 3/4 and turn it into something twelfths. And then I'm going to take 1/2 and turn it into something twelfths. Because when we have the same denominators, like we saw on the previous page, it makes it so easy just to look at the numerators and already know how to put them in order. So let's think. 3 goes into 12 4 times. So times 4. 2 times 4 is 8. 4 goes into 12 3 times. So 3 times 3 is 9. 2 goes into 12 6 times, so 1 times 6 is 6. Now, we said we put them in order from greatest to least. They already have 12 on as their denominator. So now I can look. Which one is greater, 8, 9, or 6? Well, the 9 is, so that's why 3/4 is the greatest. We even saw it on our number line. So we've got this one taken care of. Which one's greater, 8 or 6? Well, the 8 is, which is really the 2/3 we were talking about, because these are just equivalent. So we got that one. And so our least would be 6/12, but really it's 1/2. So that is those are my fractions in order from greatest to least. I prove it with the number line. 3/4 is greater than 2/3, which is greater than 1/2. Okay? But like I said, number line's not going to always work. It will work for the common factors that are, a lot of them are in simplified form. Now let's go to mixed numbers. When we have a mixed number, which we know a mixed number looks like, say this, we can use the whole numbers sometimes to put them in order and don't even have to worry about the fractions. But then there's sometimes when the whole numbers are exactly the same and we have to look at the fractions. Sometimes those fractions are going to have the same denominators. Sometimes they're not going to have the same denominators. There's a lot of work that goes into comparing fractions. Okay, so let's say we had 1 3/4, 4/5, and 3 5/6. Let's look at our whole numbers. I see a 1. I see nothing, which would be like having 0 wholes. And then I see a 3. Do I even have to look at the fractions? No, because I can already put numbers in order based on their whole numbers. If I want, let's say least to greatest on this one. Which one would be the least one? The 4/5, because it has no whole numbers. Which would come next? The 1 3/4, because it only has one whole number. And the greatest one would be 3 5/6, because there were 3 wholes. So sometimes it's going to be that easy. So always look at your whole numbers first and see if your whole numbers can help you. Sometimes your whole numbers are going to help you with a couple of them, and then you have to figure out the other one. Now, let's look at an example of when the whole numbers are not going to help us. So our first thing would be to look at the whole numbers. Well, they're all the same, so that's not going to help us. We're going to have to look at our fractions. Well, our fractions all have different denominators, so I'm going to have to do LCD. So I've got my multiples of 3, 3, 6, 9, 12, 15. My 5s, I have 5, 10, 15, 20. 15, bam, I can stop because I already see my LCM, which is my LCD. I can already see 15, 15, and 15. So my LCM is 15, which, ta-da, turns into my LCD. Once again, what in the world am I going to do with that 15? Why do I even need to know it? Do I just get to stop there? No, I have to turn these guys into 15th so that I can compare them a little bit easier. Well, look at that one. That one's already in 15th, so I can just leave it as is, right? So this one I got to turn into 15ths, and this one I got to turn into 15ths. 3 times what is 15? Times 5. So 2 times 5 is 10. So I could look at this one as 1 and 10/15ths, and that is equivalent to 1 2/3. 5 goes into 15 3 times. So 4 times 3 is 12, so I can look at that as 1 and 12/15ths. And this is the 1 and 7/15ths. Now, I'm using these to help me, but when I write them down, I have to use the originals, okay? So let's do greatest to least on this one. We all have the same whole number. We all have the same denominator. Now, which one is the greatest? 10, 12, or 7? The 12 is, but it wasn't originally a 12/15ths, it was originally a 1 4/5. So that is my greatest. So I'm done with that one. So it's down to these two. Which one's greater, 10 or 7? 10 is. Well, it wasn't 1 and 10/15ths originally, it was 1 2/3 before we made the equivalent fraction. And so, of course, 1 and 7/15ths would be my smallest, my least. But just looking at it, some of you would try to say, ooh, 7/15ths, that's got to be the biggest because it has 15 at the bottom. But remember, the bigger the number in the denominator, it really means the smaller the pieces are.